Hi guys, long time no see. So today we're going to do this educational courses around 122, and I'm posting this on my second YouTube channel because I don't want to post this kind of stuff on my main YouTube channel anymore because like there are a lot of subscribers there. There are like 50,000 subscribers there now, and I don't think even 15,000 of those know about competitive programming. So like if I post this kind of content there, there will be very few views, and if my subscribers are not watching my videos, then the YouTube algorithm will think that it's not good enough, and it will basically punish me. So that's why I need a second channel for videos that are short lived. So basically any kind of stream or screencast or anything like this will be on this channel. And I'm also sorry about this ridiculously bad camera angle. That's mainly because on my MacBook, it is so thin that I don't want to put my camera on the lid. So that's why I'm keeping it here. I think I should register for this. Yeah, but I think it's fine. Like while talking to you guys, I can just look into the camera like this, and while doing the coding, I can look into the screen. I don't know. Okay, so I need to register somehow so that I can actually participate in this. Okay. Okay, so we have div 7 something. Okay, yeah, div 7, nice. So, okay, so it is not division 7 like div 1, div 2. It is something about divisibility by 7. So, right, so we have to change the minimum. You have to change the minimum number of digits such that the resulting number does not have leading zeros and is divisible by 7. So if there are multiple ways, wait a second, I think I should open a Jamboard for this. Yeah, I don't really have, oh, I don't know why this is there. Yeah, so I don't really have a drawing board kind of app right now, so I'll be using this. Yeah. So we want it to be divisible by 7, and it is not, and it should not have leading zeros. So it is, if it is already divisible by 7, then we don't have to do anything. Otherwise, we have to change the minimum possible number of digits. Okay, and anything else? Yeah, so if it's 42, then just leave it there. Otherwise, keep changing the digits like this. Okay, so what I think is since 7 is smaller than 10, so in every 10 numbers there must be at least one number that is like divisible by 7. So something like, if I have the numbers how to write, yeah, so if I have the numbers like um, 14 and then 21 and then 28, 35 and so on. So basically what I'm trying to say is this is really bad. Okay, so you guys can skip ahead a little. I'm just going to download something. All right, guys, I'm back now. I had just paused to download this board because Jamboard sucks. Right. So, okay. So we have, yeah. So let's say we want the numbers to be divisible by 7, right? So if we take the numbers that are divisible by 7, like 7, 14, 21, 28, and so on, 35. So we will see that like there is no, there are no 10 numbers that isn't a multiple of 7 between those 10 numbers, because like since 7 is smaller than 10, so in the tens line we have a number that is divisible by 7. In the 20s also we have, in 30s also we will have. So in 40s, 50s, 60s, in like for any number that looks like 1, 2, 3, 4, 5, whatever, and then if there's an X here, this is the last digit. So just by changing the last digit, we can get the number to be a multiple of 7. So yeah, so that's the whole point. Either we will change nothing, or we will change just the last digit. So yeah, so that's what I'm going to code here. Right, so we will take the number as input, and we need test cases here. Okay, so we take the number as input, and then we will either change only the last digit or we won't change anything. Okay, So to do this, what we can do is, first of all, so if n mod 7 equals 0, then we can just print n. Let me zoom it a little bit so that you guys can see it. Okay, and then I can return from here. But if it is not divisible by 7, then we can do it just by changing one of the digits. So first of all, let's remove the last digit from here. So n minus equals n mod 10. Okay, so this removes the last digit, and then we will try every digit as the last digit. So I goes from, actually I can just do this. Yeah, so I goes from 0 till 9, like smaller than 10, and I will try all of these as the last digit. So temp equals n plus I, and if temp is divisible by 7, then this is our answer. And we can just quit it from here. Okay, so yeah, so let's try to run this. Answer should be something like this, whatever they have. Okay, I think 371 is also divisible by 7. Let's check it. Do we have a calculator on Mac? Okay, 371 divided by 7. Oh yes, so that's fine. Okay, I think the code is correct. I can print it. Okay. Is it this thing? Yeah. Okay. Should work. I know I'm going a little slow today because I'm ridiculously out of practice. Plus, I'm not very comfortable with the new laptop. Like, it's great, but you know, like I'm not comfortable with the new key bindings and everything. Okay, so this is the second problem, minority, in which we have we are given a string s, and it consists only of characters 0 and 1. So we have to choose a consecutive substring of s and remove all the occurrences of the character which is a strict minority in it from the substring. Okay. So that is, if the amount of zeros in the substring is strictly smaller than the amount of ones, remove all the occurrences of zeros. If the amount of ones is strictly smaller than the amount of zeros, remove all the occurrences of 1. If they are same, then do nothing. Okay. Okay, so you have to apply the operation exactly once. What is the maximum amount of characters that can be removed? Right. So they're asking what are the maximum amount of characters that can be removed if we apply this operation exactly once. So the operation is like take the string, like maybe they have given, yeah, a binary string like this 0 1 0 1 0 1. So we can take this thing, and whichever character is lesser in number, we can remove all occurrences of that, right? So ideally, I think it would be best to try to either delete all the zeros or delete all the ones. So yeah, so that makes sense. We should try to either delete all the zeros or we should try to delete all the ones. And I think it's always possible unless the frequency of 0 and 1 is equal. So if the total number of ones are smaller than the total number of zeros, we can just choose the entire string and remove all the ones. But what if they are equal? So if they are equal, then what we can do is we can just leave out the first character, whatever the first character of the string is. So yeah, so actually this doesn't work very well. Yeah, so what I'm trying to say is if we have like a, actually give me a second. Okay, hi guys, so this tablet wasn't working properly. I had to install some drivers, right? So like if the string looks like this, something, what we can do is there's no way we can remove more than 3 characters here, because there are only 3 zeros here, and if we want to remove all the zeros, then we can remove only 3 characters, and if we want to remove the ones, then we need to have more zeros than the ones. So we cannot delete more than 2 ones by definition. Like this is obvious. So what we want to do is whichever is less, we want to remove all of them. So we want to remove all the zeros, and then the answer would be 3. So how can we remove all the zeros? It's quite simple. We just have to do this thing, that pick the entire string and then all the zeros would be removed. But there is one exception. So what if all the zeros and ones are equal in number? Like what if we have something like this? Okay, so what if we have something like this? And okay, actually, yeah. So we have 5 zeros and 5 ones. So what do we do now if we have the equal number of zeros and ones? So we cannot remove all the zeros and we cannot remove all the ones. What we can do is we can just leave out the last character and choose the rest of the string. So what it will do is, except the last character, it will remove all the other occurrences of the last character. So yeah, so that's the thing that we're going to do in this problem. And if the number of zeros and ones are not equal, then just print the lesser one, and if they are equal, then print the whatever the equal thing is -1. So that's what we're going to do. And for this, we want again test cases. This is actually a string. Let's say it is string s, and I take s as input. And in this, what I will do is I will just count all the zeros and ones. So let's make an array for this, int count. Right, so we have the 0 counts for both of them, and I will go through each character of the string and I will just increase the count. Okay, so I have the count for both of them, and then I want the minimum one, right? So int mn equals the min of count 0 and count 1. Okay, now if the count 0 equals count 1, that means if both are equal, then we are just going to print min -1, right? Because there is one character that we can't remove, or let's say we will decrease the min by 1. Okay, or instead of this min, let's call it answer, right? So we decrease the answer by 1 and we print the answer. That's it. So let's try to, I'm trying to look into the camera a lot, and it's getting really awkward for me, at least. Yeah, 0530 looks correct. Right. Yeah, so let's see if it gets the AC verdict. Otherwise we will debug it. Okay, this is correct. Which tab am I currently in? Okay, I don't have the problems there. Okay, kill the monster. Let's see how. Monocarp is playing a computer game. In this game, his character fights different monsters. That's all games are like that. Okay, so a fight between a character and a monster goes as follows. So they have a health and some attack stats, and okay, character and the monster both have those things. So they will both, okay, so they will attack each other one by one, I think, and character goes first. So the moment someone's health becomes non-positive, that is, they have the health 0 or less, that character, yeah, so if you can get the monster's health to be less than 0, then you win, less or equal to 0. And once the character has health this and attack this, he wants to slay a monster with health equals this and that. So before the fight, Monocarp can spend K coins to upgrade his character's weapon and or armor. Okay, so he can upgrade. Okay, yeah, so this is how a lot of games work. I'm recently playing Asphalt, and there also it's something like you can either upgrade the acceleration or the top speed, and like you have to work with the trade-offs, right? So you have only limited amount of coins, and okay, right, so you can with each coin you can either increase the attack by W or you can increase the armor by A. So okay, so if he spends the coins optimally, can he beat the monster? Okay, right. So he has to beat the monster. The monster has a health and the damage, and this character also has a health and damage. And then you can spend some coins to increase the attack or the. So I think it is pretty straightforward here. The idea is just that you like it is always best to spend all the coins. So if you're spending, like, let's say you have 20 coins, and if you spend 10 of them on attack upgrades, then you will spend the other 10 on the defense upgrades. So just by choosing how many you are spending on the attack upgrades, that's all you have to do. And based on that, you will get the final health of the character, health and the defense, both of those things, health and damage, both of those things you will get for your character for each amount of coins spent on the attack. So by spending, like, once you decide how many coins you spend on the attack, you automatically decide how many coins you spend on the defense. And yeah, I think that's it. Okay, so then you have the final health and damage, and you just have to check whether you can beat the monster or not. So let's see what is the condition for that. So let's say you have the health HC and the damage DC, and he has health HM and the damage DM. So I think you should count the number of hits that you need to beat this, right? So the number of hits are his health divided by your damage rounded up to the nearest integer. So these many hits you have to do on the monster, and then you can also calculate the number of hits that the monster has to do on you. So that will be your health divided by his damage, right? Okay, so if your hits are greater or equal to his, smaller or equal to his, then you win. So this has to be smaller or equal. Why equal? Because you are attacking first. So if let's say you can kill him in just one attack, and he can also kill you in just one attack, then you will win because you are attacking first. So yeah, that's the strategy of life. Always attack first. I think we can just write the code now. Okay, so let's remove this template. Again, we have test cases. Okay, we have health of character, damage of character, health of monster, damage of monster, and then we have the coins, the W, the weapon thing, and the health thing. Okay, so we will just input all of these: HC, DC, HM, DM, K, W, A. Okay, I guess. Yeah. Right? Okay. 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 Now for we will loop on the amount of coins spent on the let's say attack upgrades. So we will loop on the amount of coins spent on the attack upgrades. It can be anywhere between 0 and K. So what this will do is we will get the int h equals, this is the new health. So h equals HC plus A multiplied by I, and then D will be equal to DC plus W multiplied by K minus I, right? Because if we are spending I coins on the health, then we are spending K minus I coins on the weapons. So these are the new health and damage, I guess. And then we have to see the hits to kill. So I like to call it HTK, hits to kill. It's used in a lot of games. I think I first used it in Clash of Clans, I guess. On the Wikia, it's given HTK, hits to kill, right? So the hits to kill are nothing but your, we want HM divided by D. This is the new damage of the character. But we want to round this up to the nearest integer. So the simple trick is to just add d minus 1 here, and when you round it down, it gives you the rounded up version, right? So this is the number of hits that you need to kill, right? So hits to kill the monster, and then there are also hits to kill you, right? I'll just write you here, right? So HTK monster and HTK you. So hits to kill you are, should have written me, I guess. I don't know, but me would be M and monster is also M, so that's why U is better. Okay, so health of the monster plus the damage minus 1 divided by your damage. So this gives you the hits to kill the monster, and okay, sorry, this is DMN. Yeah. Right. So this is the number of hits that the monster needs to kill you. So if the hits to kill the monster are greater than, actually if these are, yeah, if these are greater, wait a second, if the hits to kill the monster are smaller or equal to the hits to kill you. So if you can kill the monster in lesser hit, that means you won here, and I guess that's what we have to print. Yes. Okay, so here we will print yes, we will leave a line and we will go out of here. But if we can't do any of this, then I think we can just print no. Okay, and let's run this, see if it is correct. Okay, it works on the samples. We can submit it now. Okay. In queue. It's in queue right now. We refresh it, then maybe, oh, accepted. So now we can go to the problem D. I think today I decided I will be doing this contest only for 1 hour. So like whatever number of problems I can do in 1 hour, only those will be covered here. I have to do dinner after that. So the problem is make them equal. Okay, let's try. So we have an array of size n, okay, and all elements are 1. You can perform the following operation: choose I and x, okay, and basically do this operation, increase ai by x rounded down. So after performing all operations, you will receive ci coins for all such I such that ai equals bi. What? Okay, what is the minimum number of coins you can receive by performing no more than k operations? Okay, okay, right. Okay, I guess I understand what this is. So can we choose any x? Right, I guess we can choose any x. Okay. All right, the initial array is not given because it's 1. It's all ones. Okay. Right. So what this is that basically we are given an array full of ones, okay, and then we are given another array with some values, like I guess these are the values, yeah, like 1752 something, and then we are given another array for the reward 26, write it here, 52. Okay, these are just the reward that we will get for that thing. Yeah. Okay, and so basically we want to convert these into them. Actually, these are just 4. So is okay. So we have to convert these into them, and if we are successfully able to do it, then we get these many coins. So yeah, so it's just like a coin management kind of problem. We have to manage the coins that we are spending smartly. So yeah, so that's that. And what we want to do is we have only k operations, right? So in total we can do only k operations, and then we have to decide which operations we should prioritize so that we can get the maximum amount of total reward. So I think one obvious thing here is that we should be knowing what are the minimum operations to do this transition. Like, what are the minimum number of operations that we need to do to get from 1 till 7? What are the minimum number of operations that we need to do to get from 1 till 5? So once we figure that out, I think then we can decide the rest of the solution. So I think the first step is to figure this part out. This is the first step, at how much cost it will be to get from 1 till this whichever values are there. So since all the initial elements are 1, and since I think b is quite small, it is still just 1000, what we can do is we can just calculate the total we can calculate the total cost for I mean, we can calculate this part for each number from 1 till 1000. I'll tell you how we can do that, but we can calculate that. And once we have done that, we know the costs and we know the number of operations. So we have to do some kind of rationing, that we have to use a certain amount of coins on a certain amount. Like, we have to use the operations smartly to get the most number of coins. So I think this is like, this whole thing is a number of operations, right? So we have a fixed number of operations. Like here we have 0 operations. Here we have the, I guess, whatever number of operations. Here we have 1 operation and so on. And then there is a reward for doing those operations. And we cannot do more than k operations. So yeah, okay. So this is a very interesting question. Yeah, it just hit me. I mean, it hit me a few seconds ago, but like I was explaining at that time. So actually what we're doing here is, this is like a weight. This is similar to a weight, and this is similar to a value. This is a very brilliant question actually. And this is something like a capacity. So we have to pick some of these objects such that the weight does not exceed the capacity, and we want to maximize the value. So this is actually a knapsack problem, and I think this is the coolest problem that I have seen in a long time. So yeah, this is a very good problem. This is just knapsack. And regarding this, I guess it's a BFS to get from 1 till 7. Like from 1 we can go to 2, and then from 2 we can either go to till 4, or we can go till 3, and then from there we can, from 3 we can either go to like 6 or 4, I guess. Yeah, and 4 is already done, so we won't do this. So this is like a BFS to calculate the costs, and once we have done that, it's just knapsack. Yeah, the constants are also okay. The constants aren't very knapsack like. Doesn't this go till 10 to the 9 if we try to do it using knapsack? Okay, no. Yeah, this is these are the weights. No, yeah, so the weights will also be less than 10 to the 3, and yeah, okay. So let's start coding. I don't want to waste any time. I'll explain as I'm coding. This is actually pretty cool. So yeah, we have the template, we have this thing, okay, we have NK. This is a very cool problem. I haven't seen such a cool problem in a very long time. Like I didn't think this would, okay, I guess it was easy to think that it would reduce to knapsack, but maybe since I was explaining, I didn't think in that direction. But yeah, It's actually really cool. Like the cool thing here is that there are a lot of people who will try this problem, and a lot of people who won't be able to do this problem. And even when, like, a lot of people won't be able to do this problem even when they already know BFS, they already know a knapsack, but they won't be able to apply these concepts here. So that's why I think it's really cool. Okay, so we have B and C. Let's take both of them as input. Okay, so we got B and we got the C. Now, so what do we do now? Right, we want the BFS thing, right? So I'll just make an array like this, int distance from, let's just have like, so we want the distance to each vertex, I guess. So these are the vertices 1, 2, 3, 4, 5, and so on. And we have to run this only once. Right? So once. There's no point doing it again and again, even when there are multiple test cases. Okay, so this is like a pre-compute kind of thing. Okay, so in this, I want to calculate the cost from everything. So distance of 1 is 0, and the distance of everything else is infinite, I guess. I'm not sure how BFS works. 2 is smaller than n. I'm kidding. Obviously, I know how BFS works. Like, I don't always know what is the best way to write the code, but yeah, so I just do it in my way. Okay, so yeah, so this is this thing. Then for BFS, I need a queue, and in this queue, I will push 1, and then while this queue is not empty, we will take out the current element. Okay, right, and then from this element we will try to go to all the other elements. So right, okay, so yeah, we have to iterate on this x actually. Yeah, so we have to iterate on this x that has to be greater than 0. So let's start with x equals 1, and we can go up till x smaller than n. Like, I know we can do it in a more optimized way as well, but since this is just 10 to the power 3, since the capital N is just 10 to the power 3, I think we can do it like this. It doesn't matter. So what we want to do is we want to go from whatever this number is, from the current till current plus 1. Sorry, current plus current by x. Okay. So that's what we will do. So the next node that we will go is current plus current by x. Okay, I think that's what the operation was. Right. So once we go there, the distance will be, so let's call it the new distance will be the distance to current dist cur. I think they won't allow us to use this name dist. Like, if I compile, there will be some problem. No, let's call it just dis. So this is the distance to cur plus 1. Okay. Now, if the distance to the next node is greater than or let's say if it is infinite, because we have to visit the vertices only once. So if it is infinite, then what we can do is we can just do distance of the next vertex is the new distance instead, and we can push the next thing, push the next into the queue. And I think this should save the distances for all the vertices. But just to be sure, let's just print it once. It's always the better habit to print it. Let's print the first 15 values maybe. better safe than sorry. Okay. So no operations required to go till 1 operation for 2 operations for 3, 2 operations for 4, right? Then 3 operations for 5. Okay. 3 operations for 6 as well, because 3 plus 3 is 6. Then for 7 we need 4 operations. Okay. For 8 we can do it with 3 operations, right? I guess this is fine. We don't have to bring this. Okay. Really hard to remember the new key bindings. Okay. So next step is to just do the knapsack thing. Okay. So we can make a new vector for the costs. Sorry, for the weights. These key bindings are really tough. Sorry. So these things do something else in Windows and something else in Mac. That's why I'm having a lot of trouble. Yeah. BI. Okay, so we just want the distance to BI. And this will be our weight. We can say the WI equals the distance to BI. So we have weights at each element and we have the values also. So let me name it V instead of C. Right. So now we have weights and values and it is just a knapsack. So K is the capacity and this is just knapsack. Should I copy paste some knapsack code or write it here? Okay, I'll write it here without explaining it much. Okay. This thing and forgetting knapsack actually. So what we do is, I guess, dp 0 0. Okay, is 0. We have to fill everything with infinite, I guess. Sorry, minus infinite. I think 0 is fine. Yeah. So dp 0 0 is 0. That means like if we don't pick the first. And dp 0 wi, that is if we pick the first object, that is equal to the value. Oh. Okay, so this is the dp 0 and we will calculate for the rest. Okay. Actually, this doesn't have to be more than k, I guess. Right, so we want dp of index comma the weight, right? And this doesn't have to be more than n, and this doesn't have to be more than k. Okay, so we have two options. We can either pick or not pick the object. J goes from 0 till okay, and first option is to not pick, so that is dp I j equals just dp I minus 1 j. Okay, so this is the first option in which we don't pick. The other option is dp I j equals the vi plus dp I minus 1 j minus wi. Okay, I think this should be correct. And we will do this only if j is greater or equal to wi. Otherwise, it doesn't make sense. Right? I guess that's correct. So what we want is we want to print the maximum value for dpn. Okay, so int j goes from 0 till k. Okay. And we want the maximum value of dp n minus 1j. And that should be the answer according to me. But let's see what the actual answer is. 9020. Oh, right. I am a little wrong. I don't know which part, but some part is a little wrong. I am underestimating. No. Right. So they have a better solution than me. We want to get the AI is equal to BIs. I really think that this is all correct. Right. So probably I'm messing up the knapsack. So this test case is wrong. We have 9 coins. Really want to print the weights here. Okay. Because if that is wrong, then it's just a waste of time. Okay. 3 operations for 5. I guess that's correct. 1 operation for 2, 3 operations for 5, 3 operations for 6, 1 operation for 2, 2 operations for 3 or 4, and then 3 operations for 5 or 6. Okay. Seems correct. Right, so weights are correct and the values are correct. That means the knapsack is wrong. But how? So let me print the values as well. I mean, they are just up there, but and them together. Okay. 9 and 9 gives 18. 18 plus 5 plus 2. 18 plus 7. 87. Wait a second. 9, 9, 18, 18 plus 7, 25, and 5, 30. Okay. Yeah, knapsack is wrong. Okay. This is really embarrassing. Seems correct to me, I guess. Value. Oh, 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 wow, 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 just wow. Okay, wow. I was just directly setting it equal to that instead of doing the maximum. Wow. Okay, yeah. Ah, this is the silliest mistake I could have ever made. Correct now? Wow. I never thought I would make a mistake like this. Okay. I'll explain this again because I wasted a lot of time here. Okay. Oh, runtime error. Wow. Oh, right. Yeah, obviously. Um, Obviously we don't have to go greater than n. Oh, I didn't save it. I think I saved it. Yeah. Again. Oh, I think I didn't check that W0 must be smaller than K plus 1. Yeah. Is smaller equal to K. Right, then only we can do this. Ah, it should work this time. Memory limit exceeded on test 12. How? Not using that much memory. Oh, K is a lot. Oh. Oh yeah, I didn't notice that. Hmm. K is a lot, but I think the total number of operations cannot be too many. Let me just find the maximum distance from any number to any number. Okay. Mhm. This is the maximum distance, and I think like this thing won't be too much. So if we multiply this by n, K shouldn't be bigger than that. Right. So let me make this global. Key bindings, key bindings. Okay. So if K is greater than mx multiplied by n, then we can just say K equals mx multiplied by n. Okay, and just out of curiosity, let me print the K as well, sorry, the mx. Oh, it's just 12. Yeah, so even if n is 1000, it won't be more than 12,000. Can we still get memory limit? I have 12,000 multiplied by 1000. Okay, these many integers with 64 bits for each integer, and these many bytes, or these many kilobytes, or these many megabytes. Yeah, 91 MB, that's fine. Along with, yeah, that's it, 92, 93 MB. Okay, yeah. Yeah, see, 94 MB. Actually, not even 94, I think it's something like, just paste it here, 024. 92 MB, yeah, just as I guessed. Okay, so yeah, it was quite embarrassing, but okay. So the mistake that I was actually making, like the main mistake, there were a few mistakes here. So the first one was I wasn't checking that we don't want to go for the bigger elements. We just want to go till the capital N. And apart from that, why wasn't this an infinite loop though? I have no idea. I have no idea how it was working on my local. Yeah, so that's that. And then the this thing was there. I should have known. I didn't pay attention. But the main thing was that instead of doing the maximum of these two, I was just writing equal to here. So obviously that was wrong. Okay, so let me just summarize the solution again. So this problem is a little bit like, right? So we have to make them equal. Okay, so let me just go here. Okay. So what we have here is that we have an array of ones like this, 1, 1, 1, 1, 1. And then we have like this is the initial array, and then we have a target array which is given to us as input. So it could be like 3, 5, 70, 17, 8, 9, anything. What we want to do is we want to get from here till here using just these operations. That is AI equals AI plus AI by X. Okay, and we can choose whichever X we want. It should be an integer greater than 0. Okay, so we want to get from here till here, here till here, here till here. But we cannot do this operation infinite times, so we can only do it up to k times. Right, so we cannot do it more than k times. Okay, so that's that. But another thing is there. It's that for each of these numbers, we have, for each of these indices, we have a number of coins that we will get as a reward if we are able to do this. So like for here, we might get just 1 as reward. Here we might get 5 or 10 or 3, 20 or anything, right? So we get rewards. So this is our initial array, this is our target array, and this is the rewards array. These three things are given and we have to do it. We have to get from initial to target. We do not have to use more than, we can't use more than k operations. And we want to get from the initial to the target, and whenever we get a certain index from initial to target, we get a certain reward. So that's what we want to do here. And obviously the first thing is to count the minimum number of moves to get from 1 till a certain point, right? We want to get from 1 till a certain point in the minimum number of moves, and that's something that we have to calculate. Only after that we can proceed in this solution. So how do we do it? How do we calculate the minimum number of moves to get from 1 till any number? So we can see as an example, like from 1 we can go to 2, and from 2 we can either go to 3 or we can go to 4. Then from 3 we can go to 6 if we just add 3, or we can go to 4, but 4 we have already gone here. So from 4 we can add, we can go to 5, we can go to 8, and I think 6 also, but 6 is done here, so let's forget that. But yeah, So yeah, so something like this we can do. And yeah, so that's the point. So you can see that this is similar to like a graph. It's like a graph from 1 till 2, then from 2 till 3, and like we have edges like this. So what we're doing is we're just doing a BFS from 1, right? So this is the best breadth. Right? I'm not saying the other thing. So we're just doing a breadth first search from 1 for all the numbers, right? So from 1, 2, 3 till 1000. For all the numbers, we're doing a breadth first search and we want to calculate the minimum distance from 1 till that point. So let me show that part first in my code. Actually, yeah. So this is that part. What I'm doing here is I have the array for distances. Distance 1 is 0, then everything is infinite. I have a queue for BFS, that's just how normal BFS works. Then we have the front, pop, everything. So the next vertex, this is just the operation. So I apply the operation once, okay, and I have to make sure that the next must be like if the next is greater than the capital N, that is 1000 something, then we don't have to go to that vertex, because in the input, because in the input you can see that these values are bounded by 1000, so we do not have to calculate it for bigger values. And just like that, using a BFS, we are able to calculate the minimum number of moves required to get from any number till any other number, right? So now we have the minimum number of moves. So we can just ignore both of these arrays, right? So we do not care about both of these arrays. We just care about the minimum number of moves. So we can just remove both of these things, okay? And instead of that, we can just make another array of the moves. So like, for example, here it takes 2 moves, here it will take 3 moves, maybe here it will take 8 or 9 moves, anything, right? So we have the different number of moves, and yeah, so that's all our problem is reduced to now. That we have like if we do 2 moves, then we can get 1 reward. If we do 3 moves, we can get 5 reward. If we do 8 moves, we can get 10 reward, and so on. And we can don't only do K moves. We cannot do more than K moves. We can do less than K moves, but not more than K moves. So if you think about it, this is just the knapsack problem. This is just the knapsack problem, and this part, according to me, is very interesting, that it reduces to knapsack. So this is just the knapsack problem. How? If you consider these as weights, and if you consider these things as the values, and this is your capacity. So what you want to do is you want to pick some of these weights. Like you have to pick some of these objects such that their total weight does not exceed the capacity, which is K, and their total value should be maximum. So that's exactly what knapsack is, and this is a very standard DB problem. So obviously, I think all of you must be knowing about it, or you can Google it. Maybe you can watch a video on my main channel. So yeah, so this is just the knapsack problem, and that's what we had to do. We had to solve the knapsack. But there is still one problem. That one problem is that you can see that n is up till 1000, and this k is 10 to the power 6. So if you multiply both n and k, you will see that we get around 10 to the power 9. So that's a lot, and that is the time complexity of knapsack, the number of items multiplied by the total capacity. So it won't work like this, we know that, but there is another observation. So that observation is that these values are actually very small. So these values are very small, and I checked it by writing some code. So I checked the maximum distance of any number from 1 till whatever numbers we have. I tried to store the maximum distance, and I actually printed it, and it turns out to be 12. So this cannot be more than 12, right? So 12 is the limit for this. So what I'm trying to say is, if the 12 is the limit here, and we have at max 1000 elements, so we get 12,000, right? So 12,000 is the limit here. So if we cannot have total more than 12,000 operations, then what's the point in having a big k? Like even if the k is 10 to the power 6, to us only 12,000 is relevant, right? So that's what I did here. I calculated the maximum number of moves that will be required to get from one till any place. And if the k is greater than the maximum times n, so if the k is very big, then I will consider k equals maximum times n, because if the k is bigger than that, it will just be wasted, because we don't need more than these many operations. And then this is just standard knapsack. So just write the dp for knapsack and just print the answer, and that's all that is. So yeah, I'm not going to try problem E now because I think it's dinner time. Maybe I can at least read it once. If it's easy, I'll do it. Otherwise, that's it. Spanning tree queries. Okay, let's see the number of submissions. Only 40. Yeah, it's probably going to be tough. 1,000. Wow. I was really slow on that. Must be beaten by, I think, everyone. Okay, nobody's participating. Wow. Oh, he did only one problem. Wow, Neil was able to do all of this in just 12 minutes. It's amazing. Okay, so we have the problem E, weighted connected graph. Yeah, I don't think I'm going to do this. Okay, so that's it for this video, and I guess so that's it for this video. And I guess like if you want to watch more of these contest solutions and things like that, you can you should subscribe to this channel, or if you want more permanent kind of content that works for a longer period of time, then you should go check out my main channel. I will put the link in the description, but I guess all of you know it already. And apart from that, yeah, so if you have any ideas about what else can I do on this channel, because I don't really care about the quality of content here, like I can post almost anything. So if you have any cool ideas, it could be about CP, it could be about just for fun something. So yeah, we can do it on this channel. So let me know in the comments what ideas do you have for the channel. And that's it for today, and thank you for watching.